Hello, everyone. Welcome to week 12 of system design for sustainability. And yeah, sorry. So, this is the second last class for this course because we also have a review class for the course. And I think you guys will get the email for it, but the review class is scheduled for tomorrow, 7 to 9 p.m. So, this is Sunday. I can see the date, 15th. Yeah, 15th October, 7 to 9 p.m. There is an extra class, a special class or a review class where I'll just go over the entire course material and I will, you know, take up any questions, doubts, and otherwise also just recap everything we've done in the course. So, just to orient you a little bit on what all you can what are the takeaways from the course, to address any doubts you might have. Also, like all the assignments, if you have any remaining doubts in the assignments, we can discuss that as well. So today I'm just going to discuss the week 12 material. So some part of the week 12 material is actually just the review of the course. So that part uh, I will cover tomorrow. That's tomorrow 7 to 9 p.m. It's at a different timing, so just take note of that. And apart from that, in week 12, we have we have a different portion also, which is engineering design criteria and guidelines. And within that, you also have the ICS toolkits. That's what I'm going to talk about today primarily. And we can also discuss the previous week's assignment. So that's what I'll start with. I'll start with the week 11 assignment, and then I will go over some of the concept overview for week 12. And then, of course, as we go, you can also tell me if you have any doubts, any questions. Okay, so I'll just give it a few minutes to allow some people to join in, and then we'll get started. Okay, so let's start. I'll first start with the week 11 assignment, and then we can come to week 12. Okay, so I'm just going to share my screen so we can see the assignment. Okay, so this is week 11, and we have the assignment. So now that the answers are published, we can go over all the questions. So the first question is more of a factual kind of question, which is just directly from the slides. There's not like a whole lot to discuss, which is that the clean development mechanism. So CDM, wherever we say CDM, it is clean development mechanism. So the CDM allows emission reduction projects in developed countries to earn certified emissions, to earn certified emission reduction credits, each equivalent to 1 ton of CO2. Which of these brought the highest reduction in CO2 equivalents per annum? So these are all the different projects in India. And I mean, it's not very obvious from just the name of the project as to which project will be the most, which will give the highest reduction credits. So you should ideally remember these things as to which one, like at least the important ones, as to which one was the highest uh, reduction credit. So in this case, it is, you can see the answer, it's the Himachal Pradesh reforestation project. So next question. Carbon footprint includes the cost of resource depletion. So this is not true, because in carbon footprint, if you remember, what we do is we, add up the emissions, like GHG emissions, throughout the life cycle of a product, or or a country, for a certain time period, or maybe you can calculate your own carbon footprint. You as a person, of course, it doesn't have to be just for products. Carbon footprint can be for a whole different set of entities. So you can calculate even your own carbon footprint, and that is, you can define, like, your carbon footprint in, like, say, 1 year's time or something. So the point which you need to focus on here is that the carbon footprint calculates only the emissions. You just add up the emissions through all the uh, steps, all the processes, all the sub processes involved in something. So for example, if you are a person, you will, like, take an account of all the activities you do throughout the day, all the gadgets you use, all the machines you use throughout the day, all the objects you use throughout the day, what sort of processes you do, right? So you like make a complete exhaustive list of all of those things, and a representative list. So it may vary from one day to the next, basically. But since it's sort of a bit not so practical to sit and calculate every day, you make a representative list of typically what you do every day, or on average, so to say, and you take the sum total of all the emissions involved in all those uh, subparts of your day, so to say. But the fact remains that we are only talking about emissions. What this question is talking about is cost of resource depletion. We don't factor in resource depletion. So even if your GHG emissions are coming from, say, natural resources, we are still only talking about the emissions. We are not actually considering the resource depletion aspect of, say, energy consumption in the carbon footprint. Okay, that, I hope that's clear. So question number 2, it's the answer is false. Question number 3 is, which of these is not a greenhouse gas sink? So first of all, I hope you understand what is meant by greenhouse gas sink. So greenhouse gas sink is, a sink. What we mean by sink, like, it's a general engineering or science terminology. We call something a sink. Like a heat sink is a place where heat gets absorbed. Similarly, a GHG sink is a place where greenhouse gas emissions are easily absorbed. So, a greenhouse gas sink is a place where you can kind of absorb all the greenhouse gases, like absorb in the sense that they will be removed from the atmosphere. So, the answers are, of course, on the screen, but I hope you know why these places are called greenhouse gas sinks. For example, like the forests. So many of the forests, rainforests and equatorial forests, many of the dense forests are actually greenhouse gas sinks because they remove huge chunks of carbon dioxide from the atmosphere, and, like, they're trees, so they give out oxygen. And especially the rainforests, they have like they have a very high rate of absorption because they are filled with so much of vegetation, so many plants, so many trees, so many shrubs. So there's like very, very high level, very, very high absorption in these forests. So give me a moment. I'm just trying to share something. Okay. So greenhouse gas sinks are places like, the forest where greenhouse gas can be easily removed from the atmosphere. So this greenhouse gas, removal of, sorry, greenhouse gas removal from the atmosphere is also a part of CCS, carbon capture and storage. So storage is a broader term where, you're not necessarily sort of removing it. You may be, I mean, you are removing it, but maybe not like absorbing it. But uh, um, carbon sequestration is the more technical term, right? So, so the oceans also do the same thing. The oceans also absorb carbon dioxide and other greenhouse gases from the atmosphere, and they remove it from the atmosphere, like sort of permanently, unless you go and sort of meddle with that process and you destroy marine life and all that. That's a different matter. But otherwise, that's what they do. I'm just finding stuff to share with you. Actually, that's why it's taking minutes. Okay, and the soil is also in the same category. Why? Because in the soil, again, you have something called carbon sequestration, and carbon sequestration is basically the same thing, what I just said. Dairy farming is actually one of the biggest, one of, not the biggest maybe, but one of the bigger sources of greenhouse gas emissions. So in this, the anomaly is actually dairy farming. In the soil, you have carbon sequestration through processes like organic farming. So I don't know if you guys are familiar with this fact, but things like organic farming actually remove uh, GHG emissions, and they actually uh, make the soil better. So that removal of GHG emissions is not really harmful or some harmful or something. It's actually making the soil better as well. So which is why this is considered one of the better ways of removing carbon dioxide from the atmosphere, because you're not actually destroying anything in that process. So um, that's the answer for question number 3. Okay, just locate something. Okay, next question is, um, a company is blank when it measures its carbon footprint, reduces its emissions, and buys carbon credits to balance out the difference. So in this case, I think I explained this last time, but I'm happy to explain it once again. Let me just share my screen from the other device. Okay. So we talked about a company. Okay, this is company A. Okay, and it is giving out X amount of emissions. Okay, and now the reason for company to worry about these X emissions is not just because they care about the environment, right? Now, a lot there are in many places, especially in many other countries, there are many reasons for a company to sort of worry about their emissions, and one of them is, of course, that they care about the environment. They actually care about the environment, but many times they actually care about how much taxes they need to pay. So they may need to pay some sort of a tax tow on this, right? Emissions. They may, I mean, depending on which country you are in. In India, I don't think you have such a tax yet, but they may. So what they will do instead is they will buy carbon credits. And these credits will do what? Certificate, certificate for X reduction or offset, right? So this is what they'll buy. And when you combine these two things, you do this plus this, you get equal to 0. So they emit X, and the number of carbon credits they buy, you subtract. Okay. So this is X minus this much carbon credits. So this is what these companies call as net zero or carbon neutral. So I explained this last time also, but this is an important point. So I just wanted to clarify this. Now, a lot of times they do it because they want to escape this tax. So the reasons may be very noble that you're actually conscious about your emissions, you actually care about damaging the environment, you actually care about your environmental footprint. All those are very noble decisions, and sometimes companies may actually believe in them, but a lot of times they don't. So, but at the same time, you have something like a X tau, and they don't. They definitely care about their profits, so they don't want to pay this tax tau, which is why they actually don't want to have net emissions. They want to be carbon neutral, and this is how they go carbon neutral. They actually right. Okay. So let's go back to our problem set. So now you understand, hopefully, question 4, why the answer is carbon neutral. The answer is carbon neutral because the company is um, okay, this toolbar has changed. So when it measures its carbon footprint, a company's dashboard, it measures its carbon footprint, then it reduces its emissions and buys credits. So this is the normal way. Measures its carbon footprint, right? So you've got that, reduces its emissions by buying carbon credits. So which cover the difference, so balance out the difference. So if balance out the difference. So if you buy carbon credits, but you're still net, you're still not in the clear, you're still not balanced out the emissions, you are still not going to be net neutral on the net. Okay, sorry, I'm just trying to figure out what is the best way to use this toolbar. This is they've suddenly given the Zoom people have sort of updated the toolbar. But firstly, it looks different. And secondly, I'm just trying to figure out what's the best way to use it. Just sorry, give me one moment so I can figure this out. Yeah, measures its footprint, reduces its emissions, and buys carbon credits to balance out the whatever. So that is carbon neutral. There's no such thing as, there's no term like carbon credited. Carbon trade exchange is also, it's the name of a place maybe, but it's not what you call the company. So that is the difference. And it's, of course, it's not a greenhouse gas thing. So if you even know the term carbon neutral and you know like what it means, then this should be fairly obvious as to what the answer is here. But just to explain that whole thing about what it means to be carbon neutral or net zero. so that you remember this in case you get some other maybe trickier question in your exam and stuff. Okay, question number 5. Mechanism for compensating all or part of the CFP's carbon footprint through the prevention of the release of, reduction in, or removal of an amount of greenhouse gas emissions in a process outside the boundary of the product system. Example of investment outside the relevant product system are. Now, again, let me explain this question a little better. I want to share both the things actually. Um, the I wanted to share both the things. Yeah, I wanted to share this also and share the notepad things. Can you see my screen? No? Okay. So that's the reason why I wanted both the things actually. I wanted to share both the things. Mm, see this works. Yeah, it's not working. I can't share both at the same. So, all right, let's go here. I'll just read out the question again. So, yeah, mechanism. This question, if you want, you can just open the assignment on the side. I wanted to share both the assignment and the thing so we can read it and do it at the same time, but it's not working so well. So, this is like, say, suppose system boundary. Okay, we need this. Okay. So this is the system boundary, and whatever you do inside the system, you recycle and you do something, you take some inputs into the system, you account for it in your LCA and everything. So whatever you do in the system, whatever you do with the system after having defined the system boundary, see the system boundary, that is already accounted for in your LCA and other estimates. So when you're sort of, accounting for your own carbon footprint, right, you sort of calculating your own carbon footprint, you are considering everything you are doing to say minimize emissions, to reduce the usage of energy, maybe whatever you might be doing. All of this is already accounted for in your own carbon footprint. That is what I wanted to sort of explain, and it's explained a whole lot better pictorially. But what happens is this gives you some value. Okay, this suppose gives you some value. X is your carbon footprint, right? Now, whatever you could do to reduce X, so you want to reduce X, that you do from your own processes after having defined your own system boundary. You understand? Like whatever you are going to take measures to reduce the value of X, which is your carbon footprint or your emissions, net emissions. You will take some processes, but all those processes will be a part of your own system boundary, and other processes involved, like reducing material usage, reducing energy consumption, changing your production method. All those things will bring down the value of X, but X still remains, right? You still have some X at the end of the day. If you're a company, if you're a production house or something like that. Now, what the question is asking is, what are the ways in which you can compensate for X? It's not asking you what are the ways in which you can reduce X, which is why this question is a bit important. Example of investment outside the relevant product system. So this is the whole product system, right? This is the whole product system. So what you are doing outside the product system is what we are asking. So what we are doing outside the product system is what we will do as investment. In say other projects, or things like afforestation, clean energy production. All these are ways in which you can do things outside your product system to bring down your net your net emissions. So when you add this plus this, becomes hopefully 0. That is what I'm trying to say, that you sort of add X to all your outside activities or outside investments outside your product system. That is what you can do to further bring down your net value. This is the net value. X is what your actual emissions are. So that is why question 5, when they're asking you example of investment outside the relevant product system are. So if you're using renewable energy to produce the product, that is still as a part of your system itself. It's not outside the product system, which is why it is not the correct answer. Then reduction of water consumption in the factory, reduction in consumption. It says water, but it could be something else also. Reduction in consumption is also something you do in your product system. Investment in renewable energy technologies in developing countries. This is completely outside your product system, right? Similarly, afforestation is again outside the system. So these last two options are the correct answer. So moving on, you see any other question in which I need some diagram? Okay, so just going to share and share the assignment again. Okay, so I'm on question 6 now. So the engagement circles are what it provides a way for bringing together different constituents in integrated partnerships, offers a practical method for sensitively defining, measuring, communicating responses to critical issues. And just opening the slide. Yeah, previous week where we talked about engagement circles. So these are engagement circles, right? The engagement circles are basically between um, different entities. So industry, that is business organizations, civil society, like I said, the people, the not-profits, all those people, research-based entities earlier, academic institutions, blah, blah, blah. And then, of course, you have government institutions. So there are like 4 types of entities we were discussing, and engagement talks about engagement between these. So I just wanted to recap what are engagement circles before we talk about the question. So in the question, it's asking what do engagement circles do? So engagement circles provides a way of bringing together different constituents in integrated partnerships. It's a whole lot of language, but it's basically just saying that it creates some sort of a, dialogue between different entities and offers a practical method for sensitively defining, measuring, communicating, blah, blah, blah. Guides the city creatively through the process of understanding the inevitable tensions and contradictions, build sustainability across all domains of social life. So you see, some of the other options are actually referring to other circles, not the engagement circles. So I, I think that is why answer the first option is the most appropriate. This is a slightly more subjective question, so I'm not really able to justify it beyond that. So some of the other options sound a bit more plausible too, but I think they're like the last one is definitely not the engagement circle, it is the ecological circle. And the second last option is sort of more on the knowledge circles. The second option is, I'm not sure what if it is referring to something separate, it could be. Yeah, I think the second option is referring more to the process stages, and the third is the knowledge circles. The fourth is the profile circles. So the first one is the only one which is actually referring to the engagement circles. So that is the correct answer in this particular case. Hopefully, when you get other questions, it's not going to be that abstract, but that was just the answer in this case. Okay, next question is question number 7. This is, I think, fairly obvious. We're talking about knowing everywhere, so it is the knowledge circle. I don't think I need to explain too much here. Next is question 8. The ecological domain is defined as the practice and meanings that occur across what? So here we have like all the different options, and the correct answer is the intersection between social and natural realms, focusing on the important dimensions of human engagement with and within nature, but also including the built environment. So, I mean, again, this is a whole lot of language, but if you see the other options, they're not actually talking about, ecology at all. So you see the first option, second option, third option, they're not really talking about ecology at all. So that is kind of why the last option, even though it is some uh, like difficult language, but it's still um, you know only one which actually fits in the context of ecology, which is why it is the correct answer. Uh, so question 9, circles of sustainability is a method for. So this is, I mean, this should be kind of fairly obvious. Measuring carbon footprint and eco costs you can do with other methods also. You have, and you're not measuring anything in circles of sustainability. Actually, you're just um, using them as sort of like frameworks or toolkits for certain design processes, especially like I mentioned last time, design processes more in the urban design realm. You can't even use them directly in like simple product design because it's not really very relevant to simple product design. So this is kind of the important part, that it's mainly for creating sustainable cities and communities. So the circles of sustainability were actually created for urban design context. So they are more towards cities and communities. Assessment of parks, assessment, they are, of course, I mean, they're not correct answers. It should be 10 copies. Let's go to question 10. This is part of which dimension? Dialogue and reconciliation, blah, blah, blah. So if you remember each of the circles, you will probably remember this is from the politics dimension of the profile circles. So um, I think that's again not really that much to discuss, which is fairly based directly from the slide itself. So I think with this, I complete assignment for week 11, and we can now go to week 12. So any questions at this point?
No, madam, you can go ahead.
Okay. Okay, so week 12, like I was saying in the beginning, the last two lectures are actually just the overview or review of the course. So we have an extra class tomorrow, which is a review class. I think I don't know if you got the email already, but you will get the email tomorrow, hopefully. It's from 7 to 9 tomorrow evening. It's the same Zoom link. So you can join tomorrow for the extra review class for reviewing the content from the whole course. We can discuss the basic overview of what all we've studied so far, and also like something about, we can take up some of the questions, as in, some questions from the assignments or some other questions you may be having from the course in general. If there's any specific type of problem you want me to solve, then please let me know. I will bring some example question or something. That's not, because the course is pretty vast. So if there's some particular topic which you find a bit difficult or which you want some practice with, then I can try to create some problem set or something for that particular topic. So if not, we can still discuss some of the questions from the course. Especially I would like to focus a bit more on some of the numericals which you might get, and we'll review the rest of the stuff anyway. So the week 12 last two lectures are actually review only. So that's why I'm not covering that today, because I'm anyways going to do that tomorrow. Today we'll just discuss the content for week 12, and we've already finished the assignment for week 11. So week 12, now the first part is actually this discussion of the different parts of the second part, which is the ICS Toolkit. So let me share this. This is the lecture, first lecture for week 1. And this book is pretty comprehensive. So if you have like any doubts, if you want to read it or something, you can read this book. I think it should be freely available. So if it's not available, you can let me know. I will share the ebook. But from what I remember, I think it was available for free in Springer. These are the criteria she's given for engineering design criteria and guidelines. The book is a bit different from this. This word of warning. The book gives some other criteria, and I mean it includes this, and but it gives some more further criteria also, and they don't call it as engineering design criteria. It's just design for environmental sustainability. So that wording is different in the book, but these are the main sort of criteria and guidelines which we are going to discuss in the ICS toolkit. So what she's discussed in lecture 1 is just a drill down of each of these. So she's gone over each component and talked about all the ways in which you can, reduce consumption, for example, and then how you can minimize energy consumption, things like that. So this is none of this part is too technical or confusing. So that is why I didn't want to just repeat. It's just, it's literally just a framework and a list. This is a list of things you can do, and I think the book gives this pretty decently. So this part I'm not discussing today. I just wanted to spend some time on the ICS toolkit because that part I think firstly the toolkit is not available on the link which she's given because this is an old PPT. So that link has changed. I'll just show where you can get it from, and I've already uploaded the toolkit in the shared folder and the guide for that also. So all of these are things she talks about, which is pretty self-explanatory. There's not like too much like avoid additives which are toxic, minimize hazard or toxic materials. Like none of this is very complicated, which requires explanation. And a lot of this actually we have already discussed multiple times in the course. So there's not like too much which is new here as such. We've gone over this like 100 times, I think, in the course. So this framework just gives a new sort of structure to the same thing which we have been talking about multiple times. Right. So I'm not discussing that. I'll come to the toolkit, and all of these are actually a part of the toolkit itself. So when you talk about the toolkit, you'll see the same list. So this list is actually from that toolkit itself, which is also by the same author. So the author who has written the book, Design for Environmental Sustainability, or one of the authors, he's the main pioneer maybe in this field, but there are other co-authors also. So he is the same person who has created the toolkit also, he and his team. So that's why there is a overlap. So the place where you can actually download the toolkit and maybe some other relevant materials is actually this. So this is the different link. You can see this website, lens.europe.e, lens-europe.eu. This is the so this is a site which actually works. There used to be a Lens International website also, which used to work, I think, but it doesn't load anymore. It doesn't work anymore. So here you can actually go to the website. Much of the stuff here is what we have been studying about. And see, you can see stakeholder motivation, sustainability table, interaction storyboard, handbook of life cycle design, blah, blah, blah. All of these are things which we have been discussing for the good part of the course. And there are some lecture slides also here. So this book is also there available for free, Designing Sustainability for All. It's a really good book. You can look at that. There are some examples here for some of the other things we discussed in the course. There is a there are a lot of PPTs here for different tools which we have used. So this is a system map, all that. And this is, I think, a presentation on the same thing. This is a presentation on using the ICS toolkit for a particular case study, SDO toolkit for a particular case study. So all of these, I think, you may find a bit useful for preparing for this course. This is another book. It's a more newer book. You can get this book also. This is a fairly new, I mean, it's not that new, but it's newer than the one we have been referring to. And this is very similar to the one we have been referring to, but this is also pretty good. And it has the part on distributed economy also. I think is there, but in much brief way, more brief way the previous. These are some of the lectures. Let's go to the homepage. So yeah, the homepage has all these books. This is a updated SDO toolkit. So I think this is the same one which I discussed, but if you like, you can still check it out in case they have given some more update to it or something, because we just downloaded it like 2 days ago. No, sorry, not 2 days, 3 weeks ago. So this book, this is the book which we have been referring to, the first one, Product Service System Design. If you want, you can download it from here. I've already uploaded it, but if you don't have it yet, you can still download it from here. And this is something from their conference, stuff from the conference. So this is just to tell you that all these things are available. If you want, you can check it out, because we haven't, I mean, we have discussed a lot of these things in the class already. At least, I mean, I did, but there still may not be sufficient time to discuss everything. So see, like these are 2 case studies for furniture and clothing for the ICS toolkit. So after we discuss it in the class, you can probably check this out on your own and see how it works. Okay, so this is the website. You can note down the link, or copy the link if you want. The link is visible, I think. Lens Europe. If you search for Lens Europe, it's very simple. It's lens-europe.eu. And from there you can find everything else. So you need to create an account. So you create a username and password, and you can download. So let me share the toolkit. So this is the most updated version of the toolkit. I think what she has discussed in class is also the same version. So I think this time we don't have any point of conflict, because the last time what she was showing was an older version, what we were doing was a different version, like that. So this is very similar to the SDO toolkit. So we discussed the SDO toolkit few weeks ago, and we talked about how it generates a radar diagram and everything. This is very much very similar to the SDO toolkit, but there is one difference. In the SDO toolkit, I mean, the basic structure and the basic visualizations are very, very similar. But I wanted to first point out what is different. So the difference between this and the SDO toolkit is, firstly, the SDO toolkit is more, for system design. It's not really meant for product design. I'm just trying to see if there is a way to hide this top toolbar. Do you know how I can hide this top toolbar? Because I don't, it covers up like half the screen. I don't know why they made Excel like this. Isn't there something like a full screen view or something in itself? Because it just leaves us only this much part to view the actual file. That's all. This is worse. Okay, never mind. I'm doing. Yeah, it's fine. Okay. So the difference is that we were doing it for a system design. So when we were talking about sustainability in the SDO toolkit, we defined sustainability in terms of environmental, economic, and social. So that is why we had only those three categories in the sustainability um, basket. But here, what we have is very different criteria, and the criteria is what we discussed in the first part of the week 12 lecture, which is all the methods by which you can reduce your environmental footprints. So this is actually, all of this is a part of life cycle design. So I don't remember us discussing life cycle design in that level of detail earlier, but if you see the logical flow of design process, we discussed life cycle design. I think after we discussed life cycle assessment, which was week 3 or 4 or something, right? So this is all a part of life cycle design, because in life cycle design you are actually considering all the different ways in which you can remove, in which you can reduce your environmental impact. So here you see, we are not talking about um, social dimension or blah blah blah, because this is talking about one product. When we're talking about design, life cycle design of one product, life cycle design is a methodology in which you try to reduce all the defined metrics, values of all the metrics, where say reducing consumption, minimizing toxic waste, reducing emissions, making energy more renewable, all the whole list. So here we don't have anything like a social dimension or an economic dimension or anything. We're only talking about the environmental impact. And what is the categories for the environmental impact? So here we have LCD strategies. LCD stands for life cycle design. And these are the strategies. So this is basically what we discussed in first part of the lecture. Here they have 6. She's taken 7, but those 7, 2 are sort of merged in one kind. So first is use, extension, intensification, then resource consumption reduction. Here they have combined material and energy. In the lecture, I think she's taken it as separate. Fourth, no, they combined it in the tab. It still says 2, 3. I don't know which one she's merged, but anyway. Material life extension is extending the life of the parts, materials, all that. Then there is toxicity reduction, and of course resource conservation and biocompatibility. So we've discussed these multiple times, so I don't think these categories by themselves require too much explanation. I'll just start with what the toolkit does. So the toolkit sets these 6 criteria for your so I think somebody has requested an AI summary of the meeting. You could do that. But fair word of warning, I have created the AI summary before and it was not that accurate. It kind of misunderstood what I was saying. So you can use it as your notes, I don't mind. But just be careful that it may be wrong in some places. So you should just take it with a pinch of salt. So I've generated the AI companion summary for the call for the meeting. It generates a file and sends it to me. I'll share it if I think it's okay. Okay, coming back. So these are the 6 categories in which we're trying to reduce our impact through our life cycle design. So suppose you already have something you want to design, right? Like, suppose I take something like, yeah, something like these earphones. Right? And I want to redesign it. I want to find a new way to design it so that I'm sort of clocking fewer carbon footprints and reducing the toxicity, all of that. So these are the 6 categories in which I will be measuring my design, in which I will be populating ideas to reduce my impact, in which I'll be doing the whole drill. So once we do that, once we finish populating ideas and things like that, we actually go to see how much our design is actually changing. So this is the basic flow. First, you do an impact. First, you do an assessment or evaluation of your current state of affairs. So it may not be my product. It may be some other company's product. I want to create new set of earphones which are more sustainable, right? So I take the existing set of earphones, which are kind of give a fair idea of what things are like in the market, and I do an evaluation for this. This evaluation I enter into this spreadsheet, and then what I do is I populate ideas and I see all the ways. I go through that entire exhaustive list of how to reduce the impact, and I come up with ideas for how to achieve that. So all this, like this whole list of how to reduce consumption, how to reduce and use more renewable energy, how to reduce toxicity. Each of these categories has its own subparts. You go through that entire list and you brainstorm and you come up with ideas for all of those items. Then you enter those ideas in your idea boxes when you have idea boxes. And this list here is right here for your reference, basically. And after you have entered these ideas, you come to your final evaluation for your actual design. So what you do is you had an existing scenario. On top of that existing scenario, you assign the priorities like we did before, how important something is. Then you come up with a list of ideas for how you will improve that. But this is the part where these tools actually help. When you're designing just on the drawing board or just on the sketch pad, you will come up with a lot of ideas for sustainability, but you won't know how effective all those ideas together are, or if some idea is worth implementing at all or not. Because you may implement an idea and make its impact in one category better, but it may completely destroy some other category, right? So suppose you use a new material, so your toxicity has reduced, or your material longevity has increased, but maybe it requires a whole lot more energy consumption. So you are increasing your energy consumption by a whole lot by changing that one material alone. So these things you're not able to really measure in a subjective way. You can't actually just think aloud and talk about it and discuss and think that, okay, let's do this because this idea looks better. So what this tool helps you with is that if you have a bunch of ideas, you have a bunch of things you want to try. First of all, it helps you arrive at that list of what you can do. Secondly, it helps you assign an importance or a priority level to each type of sustainability or environmental impact that you want to change. And then it helps you see if you implement those ideas, how much is your design going to improve? Because maybe you are making you're getting an incremental change for something which is very low priority. So is it really impacting your design in a big way? It might not, right? So those things are kind of captured best by this, and that you can visualize on your radar diagram. And what level of granularity you want to see it as, see it at, is captured in these 3 types of diagrams: one is simplified, normal, and this summary. I don't know why they call it summary. It's the deep evaluation actually. So summary is the opposite of deep evaluation. I don't know why they call it summary. But anyway, that is what they called it. So summary is actually the more detailed evaluation. And this is the part where you actually do the deep evaluation, EP1, EP2. I'm just giving an overview right now, then I will go to all of these separately in detail. And then you can see in the radar diagram, whether it is actually, what is actually making sense, what is not making sense. So, okay, so let's start from the beginning. So this overview was just to tell you what the tool is actually good for and how it is different from, say, the SGO toolkit. So this is the start page. Life cycle design strategies is basically just a summary of the strategies, whatever we discussed. Then the second part is qualitative assessment of existing product or system. So you can use it for system design also, but it's not really in that same kind of a methodology which we use. We're not using MSDS here. This is life cycle design. That is important to remember. MSDS is a completely different methodology, and life cycle design is a completely different methodology. So we do a qualitative assessment. Now, I wanted to highlight that part because we are not actually measuring something here. You're not entering numbers. We are not actually talking about whether you're making whether the emissions are 10 units or 50 units. We are only doing a qualitative assessment that whether it is actually good, bad, ugly, that kind of an assessment, not whether it's 10, 15, or 200. So we're doing a qualitative assessment. Then we're talking about functional unit and priority improvements. So we talk about, what are the improvements in this system. Eco idea boards is where you populate your ideas. And then we do the evaluation of your design, life cycle design. And what type of evaluation can we do? Simplified, normal, or deep. These are three types of evaluations which you can do. And once you've done this evaluation, you can see it on the radar diagram. So now the sequence, you see at the bottom, these tabs, this sequence is a bit odd. So, don't get thrown off by the sequence. They show you this, then they show you the radar diagram, then they show you the idea box. It's a bit off. The radar should be in the end or something, but that's just how they have put it. And there's no point in messing around with it because they've sort of hard coded it into the whole spreadsheet. So, um, before I get started, any questions so far? Okay, so if there are no questions, we'll start. Just give me a 5-minute break. I'll just have some water and come back because I've been talking for more than an hour. I'll just be back in 5 minutes and then we'll discuss the ICS toolkit and an example.
Madam, it seems your mic is muted.
Oh, sorry, I didn't realize my mic was muted. Thanks. I thought I have unmuted it, but somehow it got muted on its own. Sorry. So let me go back. Yeah, I was saying that from the start um, page, you can see the life cycle design strategies if you want, and you basically you can see the guide here also if you want. It's the same thing. This link takes you to the toolkit presentation, the PPT, and I'll show that PPT also. It's actually the same thing, but if you want, you can use it for reference. But we'll start with the rest of it for now. So the second thing is a qualitative assessment of existing design, existing product or system, and this is the checklist for the first item. The first item is use extension intensification. Use meaning like you're trying to elongate how long a user uses a product, because if the user is using the product for a long time, obviously the energy consumption, resource consumption, everything will be much lesser, because you're instead of using if you're using one iPad for 5 years, the energy used to manufacture an iPad is lesser, and energy for running the iPad may be the same, but energy used in manufacturing of iPads is lesser, rather than you using, say, 3 iPads in 5 years, right? So that's the idea behind it. So similarly, there are other ways in which you can reduce, elongate the, um, the what do you call it, the life of a product, basically. So this is the whole checklist. I'm just giving one or two examples here. This is the entire checklist in which they're talking about if it's a one-time use, or if it is something which has a very short lifespan, like, maybe just 6 months or something. Like sometimes you buy these really expensive digital products, but they don't last more than 6 months. That's a design flaw. It's not, it's not something which is okay. We just live with it. We just kind of make do with it. But it is essentially a design flaw if you're selling something not just expensive, but which is taking up so much of energy and materials and its manufacture itself, but it's lasting only 6 months. That's a design flaw. We need to see it as a design flaw and fix it as a design flaw. So there are, products which have a very short lifespan, and then there's the packaging. Then there is the, how difficult it is to repair or maintain it, because say suppose you buy something but you cannot get it repaired, so then you automatically you'll be forced to discard it. And the first problem you have with it, even if you want to use it for a longer time, even if the product is not completely damaged, but if it is sort of broken or it requires some repair or maintenance, but you can't get that repair and maintenance, then you are forced to use some other product. And also you will not want to buy that product more, because you can't repair it, so you will be forced to move to other products which are maybe even less sustainable, but they have repair and maintenance. Then, is it technologically obsolete? Is it aesthetically obsolete? Blah, blah, blah. So there are a whole lot of checklists. You can see where the current design stands. So this is not a checklist or a suggestion for improvement. This is where your current design is standing. What is the current status quo? And how much is this important to you? Here you assign that priority to it, the low, medium, high, none, whatever. So I've assigned medium. Once you assign a priority here, it will change here also. So you can see this contrast is bad. It's a bit difficult to read this, but there's nothing you can do. I don't think you can change the color of the fonts here. Anyway, so make sure that this has changed here, because sometimes you may think you have changed it here, but it has not. It's gone back to the old one or something. So here you can write something, notes for yourself if you want, your own evaluation criteria. Like, okay, you can give specifics of what is not working or what is not, functioning in an optimal way as per you for your product. I mean, for your product, as in for the product which you are evaluating. And this is sort of like an important way to capture all all the things for the existing, what do you call as, um, market survey, research survey, user research, all those things are kind of, this can go into all of those reports and presentations. So this whole toolkit, you may not necessarily use it as it is in your presentations. But if you're a company, or if you're a product designer, or if you are a startup, you would want to do something like this because it concretizes your assessment, your ideas, and your measurements in the end. Not measurements in the concrete, in the numerical way, but measurements in a subjective, in a qualitative way. This is a very good qualitative tool. So you can take some of the criteria, assessments, and all of this can actually go into your business pitch deck in the end, if you are a startup, or if you are pitching a new design, even in a company. So this toolkit is kind of handy for that. So similarly, like, here you can sort of click on this, I think. Yeah, you can click on this and it'll take you to the next one, next category, material consumption reduction. And this is a checklist there. And you again write your evaluation, you assign your priority, put low here. You can see what works, what's most important for you. You can click on the next one, energy consumption reduction. You can assign priority something else here. This is again the checklist for that. You see all these things and you see where does the product stand in this context. Then you go to material life extension. I put it as, sorry, yeah, I've left it at medium. And this is the checklist for that. So you see all these parts, all these points, and see where does the existing design stand on all of this. And you write your notes. So all of these notes, you can compile it later on. It's just helpful to have this kind of a guideline, this framework to capture these, sort of insufficiencies in the design. So if you're writing here, then it doesn't click here. But if you click somewhere outside of this this text box, then this becomes clickable. The toxicity reduction, maybe this is medium priority. This is a checklist. You enter something here. Whatever is the priority, it gets updated here. So see, all the priorities I have entered have been updated here also. Next is resource conservation, biocompatibility. This is low, or let's put none here. This is not a part of my design at all, perhaps. So it's updated to none. So now if you see the radar comes later actually. This is still just the evaluation. Radar should be unsimplified. Yeah. So radar comes later. That's why I get confused when they put the radar here. I don't know why they do that, but anyway. So now you come here to the ideas, and after your whole assessment, evaluation of your design, you can kind of go through this whole checklist for use extension intensification, how you can actually improve it. So when you go to the first E idea one, right? This E idea one is for use extension intensification. It's in the same sequence actually. And now this is the new checklist. I mean, not new checklist, but this is a more detailed checklist for how you can actually improve your design in these categories. So here you see all these are ways they have given. This is maybe a bit more readable. I don't know why they have kept such terrible contrast in this spreadsheet. I mean, they could have just made this black so people can actually read it. Like for a design toolkit, this is very poorly designed. This contrast is so bad. Like, how do you read this light gray text? Anyway, I'm sorry, I'm griping, but if you're designing something for design people, at least design it well. So this is design feedback on the toolkit. So anyway, you can see all these are suggestions for this use intensification. And based on these suggestions, you can populate your own ideas. So they have just put a text box here, text box there. You can have a whole bunch of ideas. This is sort of like post-its, right? This is, you know, how many they put here. Oops, what did I do? I clicked something. Yeah, sorry, I'm not messing around with this thing. Let it be the way it is. I accidentally clicked something and then I started doing errors. So anyway, this is just a whole bunch of text boxes into which you can enter your ideas. You can enter your idea one, something, blah, 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 whatever, right? This is just for your uh, personal notes. And these are the ideas which you will actually use for redesigning your product. So these are the ideas for your redesign, how you are going to improve it. This is the checklist. This is how you think you can use these items from the checklist to improve your design. Similarly, you go to this one and you populate ideas for this one. You go to this one, you populate ideas here, blah, blah, blah. So do the same thing for all these categories and you get a whole lot of bunch of ideas for how you want to redesign the same thing, right? Now you have at the end of this, at the end of this category, the last category, resource conservation and biocompatibility. Here, now by now, you have finished generating all your ideas with which you're going to improve your performance in each of these categories, right? Then we go to the simplified assessment or evaluation. So after this population of ideas, we go to the simplified evaluation. Here you see on all of these. So this is, it's a self-assessment, okay? It's not something the machine is assessing you. This is something you are assessing your own self. So what you do is you go through all these lists in the use intensification extension. You see all these criteria they have given here, and you see how you're doing in each of these. This is, you can type here. I think it should be fine. But eventually you can, you can type your own notes here. It's good, it's bad, this is better, blah, 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 whatever, right? So in the end, what is it? Based on all of these summary, you take a final assessment of what is it. Is it an incremental improvement? Is it no improvement? Or is it radical improvement? Is it worse or is it not applicable? So you do the same thing in each of these. These are just your own notes. If you want, you can enter it. Right? This is not something which is a field which is going to be used in the evaluation. But these are the things which you actually enter as the final assessment for that particular category. And you see the priority is already entered here. Medium, low, medium, high, whatever. So whatever had entered earlier, that has gotten updated over here. So once you are done with this, so for example, here I've entered all of these radical, radical, incremental, no improvement. So I've entered all these here. So what the sheet does, what this toolkit does is it takes a priority, it has different values assigned to different priority levels, and it takes the improvement. Again, different levels of improvements have different values assigned to them. So I don't know what values they have assigned, but just for our understanding purpose, 0, 1, 2, 3, 4 maybe, and similarly maybe incremental, and these are 0, 1, 2, 3, 4. So if you multiply 4 by 0, you still get 0, right? So this is, say suppose I say this is incremental improvement, but it will not make any difference because when it is not applicable, then it's 0. So, the value still remains the same. So this toolkit will take your responses for all of this, the priority and the level of improvement, and it will generate some final scores for each category, and it will generate a final, make this bigger, clearly readable, and it will give a final assessment of your redesign. It will show you how many are worse, how many are no improvement, how many are incremental, and how many are radical improvements. And it'll take this figure, if I can change it, but it'll, okay. So it'll take this figure and it'll take all of these values and it will multiply and sum it and give you this final figure. Now, once when you save it here, make sure you remember to save it. Then you go to the radar diagram. And in the radar diagram, now you can enter the simplified view. So now in the simplified view, you can see that it actually generates a diagram, which is, reflecting the values you entered for each of these. So this resource conservation, toxicity, um, material life extension, energy reduction, material reduction. All of these are the values you have entered. And this diagram shows the final evaluation for your simplified assessment. And here improvements, this is showing the shortcuts, the shorthand for all the improvements. And this is the priority level. So the letters here, why it's showing this is H. Is not correct. It should have been U, right? Not applicable. No. Should be taking this on its own. Anyway, I mean, I think it's showing the diagram correctly, but somehow it's not putting these letters correctly. See, at the bottom where it is showing priorities, these priorities, it is showing these properly. And these improvements, it is showing properly what we entered. I'm just making this bold so it is more readable. But in the diagram, I think it's not rendering this priority, it's not rendering. The improvements it is showing, and this is what is this? Minus is worse, equal to is same, plus is incremental, and plus plus is radical. So these circles represent these different levels of net improvement or net, evaluation of the improvement. So this is the final assessment in the simplified version. So the rest of it is done pretty much the same way. Again, this diagram is sitting here in the wrong place. It should have been here. But anyway, there's nothing we can do about that. Then we come to the normal assessment. So this is, again, it is a self-assessment. It's not a machine assessment. You are assessing the current state of affairs. You are only populating design sustainability ideas, and you are assessing how your ideas are performing overall. So it's a net assessment and it's a self-assessment. So in each of these categories, now you can actually see, remember in the last simplified view, we were not adding anything here. This is just for our personal notes. If we wanted, we could add, but this was not getting added up anywhere. Only the final, whatever you add here was what we were eventually considering. In this one, in the normal view, you are actually grading each of these subparts and assigning a level to each of them. So here you can add worse, here you can blah, 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 whatever. So default value is no improvement, but you can change these perhaps. So, you can change all of this and changing it so you can see something in the diagram, otherwise you won't see anything in the diagram. Okay, so I'm just updating these so I can show you the diagram. Okay, So let's save this. This is score. Okay, I can't change. Right. So you see, you entered some value for each of these subparts, each of these subcategories. It will show a final score for that category. So for use intensification, you have 48%. This one you have 54, where you have 57. So this is like it has an inherent calculator, inbuilt calculator, which calculates the score for each of these after you have entered your values. And then this is the final score, which it calculates based on everything you've entered. And then it will show you a summary here at the bottom. So this is when you really want to drill down, for each subcategory and get a very detailed overview. So after you have updated it, save it, then go to the radar diagram. Here in the choose level, choose the normal level. So now you see the diagram looks different because I wanted to see how it looks after I have updated in the normal view. So you see, after I have given all the level of detail and everything, the diagram looks very different. And you can see that the whole thing is updated here also in the bottom part. And similarly, when you go to summary, it's even more detailed. Right? So they're adding different levels of details, different diagrams. In this, mm, okay, this should be this should it's wrong. What you're supposed okay, this is in one. Is off. So here you see it's supposed to be one. I'm supposed to add 1 or 0 for each of these. Oh, sorry. Yeah, I'm really sorry. I was looking at the wrong sheet. So here the summary, you will get the summary as generated from a detailed evaluation. So you see, okay, this is why it's called a summary. Actually, now I get it. I was getting mistaken by the word summary. So this is summary because it is a summary of the deep evaluation. What you're actually doing is here. In the deep evaluation, you have this very detailed, evaluation for your each category. So EP1 is for category 1. I don't know why they call it EP, but EP1 is the detailed evaluation, deep evaluation for the first category. And in this, you have those same sort of questions in the same categories. You see here, you go to 2. Similarly, you can go to the next one, right? Then the next one. Each of these, what you have to do is in each question here, you either enter a 1 or you enter a 0. A 0 you don't need to enter, but you can enter a 1 for whichever answer matches your response best. Yes, partially, no, or not applicable. So you can enter 1 in the box which you think is most relevant to your answer, and remaining you just leave blank. So here I entered this, here I entered this. The question is, have tolerances been defined accurately? You say yes, or partially, or no. Have the batch acquisitions been optimized? Say yes. Have stock list control systems been optimized? I say partially here. Then have transfer systems of materials and semi-finished products. I say no here. Similarly, for each category, I enter a 1 or a 0, a 1 in the box in which is most applicable for each question. And in the end, it will show this total answers and total summary and will calculate the total percentage. So similarly, you go to each of these, you fill out this whole thing. It's a very detailed thing because you see this, all of these are very detailed. So you can see here there's a link to the summary. So after you have filled all of these, see all of these are links actually. So you can go to this particular, you don't have to scroll at the bottom. You can also just go to the summary table, and each of these entries are actually spreadsheets on their own. So you click on this and it'll take you to this one. You click on this, it'll take you to this one. Similarly, so for each of these subcategories, we fill out one sheet on its own. And for each of these subcategories itself, you have a whole list of questions. No, in that list of questions, we are entering that, yes, partially, no, blah, 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 right? This is like a very detailed level evaluation, and usually people don't do that level of evaluation. But for example, like, maybe your project is supposed to be more of the selling point of a product itself is, say, suppose sustainability or environmental impact reduction, or you need to show this for some approvals or get government funding, blah, blah, blah. So in all those scenarios, this detailed evaluation can actually be very useful. So in this summary, you will see, the whole final values here. And when you go back to the radar diagram. Yeah, here. You select this level as D. So now, because I have really not filled it out much, I've only just filled out one category, one subcategory or something. You won't see much here. But once you actually fill that out, it will generate a more detailed type of diagram, basically. Okay, so this is the overall approach we use in the ICS toolkit. And if you want, you can see the case studies. There's a sample in, I think, the same folder. I've shared the sample also. Let me just show you that. So this is some project in clothing, which they did. They've shared the usage of the ICS toolkit for that. Lifecycle design tools for clothing. You go here, they have sort of changed the language of the questions for their particular product. That these are the data diagram, looks very bland. Okay, they've not filled out the whole thing. So they've just modified the questionnaire here for that, for the clothing things. I thought they would have filled it out, but they've not. So then it doesn't really make sense. But I thought they had actually filled out the whole spreadsheet for their category, but they've just modified the questions. So yeah, I mean, if you can go through that if you want, but basically it's an example of how you can just sort of tweak your questions or modify your questions for specific type of product. So let me just also show that PPT. So this is the guide which is mentioned for ICS toolkit in the spreadsheet. You can see this is, this talks about the same thing, which I have explained, but if you want, you can go through this. It shows the same thing in a more detailed way with diagrams and arrows and things like that. So you can go over this. So it's just a useful document. If you feel a bit confused or a bit lost, you can just refer to this guide on how to use this. So this gives a little more detail and all of that. It's actually, it's the same as what we discussed. This is just something for your reference once we have finished if you want to go over it. Right, so I've shared this. I've shared this already in the shared folder. And I think this kind of finishes the ICS toolkit. And the assignment is still, I think the submission date is not finished for the assignment for week 12. Let me see, when is the submission date, due date? Okay, so it is still 18th, so we can't discuss it tomorrow either. But okay, if in the assignment, if there are any questions after the due date, you can post it in the discussion forum, and either me or somebody else will reply to. Okay. I think that is pretty much it. Anything else you want to ask? Any questions?
No, madam. See, madam, just one thing. I've been going through all the week's content, but more or less concepts seem repeated. Actually, there are only
Yes.
4, 5 key concepts. One is the product service system, life cycle approach, and this system design, use oriented, or but the key concepts, it comes down to only about few things, and everything is a lot of text explaining the same thing over and over. I don't know where, am I so how to make sense of so much, because no, whatever you write, if you give the same thing to another organization, they use it in different words, they write the same thing. Okay. So, for example, let's say how to ensure sustainability for a product. One is to use a life cycle approach, wherein that not only at the time of manufacturing, but also delivery, but also use, but also at the time of disposal, taking into account the whole thing, and then assessing the impact on the environment. Okay, that is the key idea. Okay, but breaking down into some circles, blocks, different points. Actually, that is somehow I don't know. I seem getting lost reading the same thing over and over.
So say some of these are just toolkits which you can use. You don't necessarily, in your real life, in your real assessment or design, you don't necessarily have to use these toolkits. She's just gone through one. So in the beginning itself, actually, I had said this, that this is one of the approaches given by one researcher in this field. This is not like a very standardized thing so far in this field, design for sustainability. It's one of the prominent research groups, one of the prominent organizations, that I accept that, but it is still not like a universal code for design or something. So you can come up with your own design methodology or method, or you can adapt all this to
Yeah,
whatever you think makes sense for you. And
exactly.
this is like they have given all the possible tools which may help you, which may not help you, because if your system design is something where these tools are not making sense, you can of course use something else. So
Yes. So
it's already just 1 minute. Just give me one moment. Somebody is asking a question. So I think Santosh ji is online as the other participant. So there's a shared folder. I think maybe you have not realized that there is a shared folder. So if you see the Swayam portal, there is a link to the shared folder there. It's just they've not shared it properly. That's the whole problem. It's the last week and still people don't know that there is a shared folder. So if you see here, this is a Swayam portal. This is a link, problem solving session, July 2023. It's not just for July, it's for the entire course. If you click on this, it will take you to this. I don't know where it's taking you. Here, you click here, and then it should take you to the spreadsheet. Yeah. So here you have all the links of the previous live session videos. And this is the shared folder, Google folder, in which I'm uploading all the files I'm sharing in the class. So you can go here and you can download all the previous materials I have shared and all today's things whichever I discussed. It's already there in the shared folder. There's also the website. I shared the link to the website while I was explaining class. Yes, I think lens your EU. I was actually showing this. I think maybe you were not joining or you were not following. But this is the website where you can download other learning materials if you want. Some of the things I have shared are from this website. And they're all freely available. So if you want to explore this website, you're welcome to. This is by that same professor, Carlo Vazzoli. He and his research group and team have made all these resources available. So for these tools and stuff, like, I mean, for the coursework, I'm guessing they are kind of important because that is sort of forming the bulk of the course. But in your actual design, whether you use it or not, it's entirely up to you. It's not like a standard methodology, like, in some of the engineering sciences and engineering streams, some methods are pretty standard that, you do it this way. But this is not the case in design. Like there's no, apart from the broad design thinking approach, which is almost universal by now, there are very few things in design which are universal. So this is like just one of the methods or some of the approaches which people have used. You are more than welcome to modify it. But yeah, when it comes to things like life cycle assessment and all, those are pretty standard because they're not from design at all. So life cycle assessment is actually a method which comes from environmental engineering. So that method is pretty concrete. It is a pretty standard method in all environmental sciences, and it can be used for different metrics, whatever you want to measure, like biodiversity loss, air pollution, water pollution, blah blah blah, whatever. So that same method can be used for all of those, and it's a very standard one. So apart from life cycle assessment, all the rest is like research actually in methodologies for design. So it's up to you. If you want, you can use some of it. Like I'm also sort of a little more mathematical or hands-on type of a person. So yes, some of the parts I feel like yes, there is a lot of literature to it. But if you understand the key ideas, I think you should be good. Like if you understand the key ideas and if you understand the methods, what we are doing in that particular method, I think you should be fine. So this discussion we can continue tomorrow in the review class where I will go over the different modules and what we can focus on in those modules. Okay, so if that's it, then I can end the class here and we'll continue the discussion tomorrow because tomorrow is the last class. Actually, this is the last class for week 12 for the coursework, but there's a review class which I had requested. So tomorrow is a review class where we'll review everything from the course. Any questions you may have from the course, basically. So is that fine? Okay, so then I will end the class here and I'll see you guys tomorrow. Thank you.